I'd like to welcome all my fellow speakers and panelists. Also like to welcome all the attendees to the ARC forum. We can pretend we're down by the swimming pool in Orlando, Florida, although Christopher Castro can pretend better than us because he's already in Orlando. That's where he's living. The most of us, maybe we are dealing with a little bit different situation today. In fact, we have had a lot of challenges. Just a couple of introductory things. I will start to present first. Christopher Castro would present second. We've lost a couple of our group today, in part because they're so much associated with the electric grid down in Texas and Austin. Tom Pierpoint, is the vice president of technical operations there. And you may have heard that the electric grid in Texas was very challenged. There was so much demand for electricity, they had to go to rolling blackouts for the first time in 10 years. And in addition to that, the market price of electricity jumped up by a factor of 10,000. So that actually will play into some of the things we'll talk about today because very important things. And in any event, as we get going, each person will have to introduce themselves. Please submit your questions and answers in the Q&A. If you get them in the chat, they might not get recognized, but welcome aboard. And so we're gonna get started directly. All right. So my name's Rick Riss. I'm a senior consultant at ARC. I have a background in chemical and electrical engineering. I've done a lot of work in the chemical oil and gas industry. I've also worked as an analyst for ARC and studied things like grid scale batteries, microgrids, transmission and distribution SCADA systems, and substation automation. So this is, definitely in my ballpark. I'm also a light commissioner in my current town. So I mentioned today that we're missing Tom Pierpoint because he's out there, climbing poles or at least assisting other people climbing poles to get power back. I know there were several thousand people in his Austin area that were without power. And we've known that we really like to have electric power, particularly when you're in Texas with pipes in a crawl space, uninsulated crawl space that can freeze and cause a great deal of trouble. We've also got news from Eric Effern that he picked up COVID-19 within the last 10 days and is not in good enough condition to present. So we'll do without these, and Christopher Castro and myself will be the major presenters. We also have a lot of expert panelists with Chuck Newton and Jet Winter. I'll let you, each of you guys introduce yourselves as we get going on that. So one of the clear goals that I've always had for electric power is it needs to be highly reliable, it needs to be low in cost, and it needs to meet environmental compliance. The high reliability is increasingly important in our way of life today. The cost of businesses to be without electric power is enormous. If you have a gas station and can't pump gas, you're out of business. If you're a bank and your banking machines can't get people cash, that could be a real problem. That was a huge problem in Puerto Rico when they lost power there. The cost of reliability is just absolutely so important, and actually utilities are actually penalized when they have too many outages or too short a time to restore from outages. We also need low cost just in general to help our whole standard of living, but we particularly need low cost today because we would like to see low cost electric power displace a lot of the fossil fuels that we're currently using for heating buildings, for driving vehicles, and low-cost electric power makes it more economical for converting fossil devices to electric. Mini split heat pumps replacing oil heat, for example, here in New England. Obviously the environmental issue has always been an issue. we've been able to do a lot of work with our fuels over time. We've removed sulfur, we've removed or reduced carbon monoxide, we've reduced unburned hydrocarbons, we've reduced nitrous oxides. We're having a little bit more problem though with removing CO2, and we'll talk a little bit about that. So I would like to mention that we're also conducting a survey that will help to stimulate our panel discussion today. And Alan should be able to put some of these links to this Mentimeter survey into the chat box so you can be able to see them. And we'll, at the end of our presentations, we'll show the results of this survey and use that as a basis for getting a panel discussion started. I think that one of the interesting things is even within the technical community, there's a lot of differences of opinion of how we're going to power this future electric grid. There are some that suggest that we can do it all with renewables, but then there's a big storage problem. There are some that suggest that we must have nuclear, all right? But nuclear is also not necessarily a dispatchable energy resource, because even the first nuclear power plants had installed pumped hydro storage to help balance the load. And then there's other activities with carbon capture and storage, and batteries become a generator at times, and as does gravity, hydrogen, and compressed air, and other means of storing. And then there's the logistics and control and automation of the grid in terms of its connectivity and some of the demand response issues. So anyway, these questions are kind of interesting. We'll definitely discuss them, and I'm sure that we could get some, I don't know, heated discussions, or at least controversial, or lots of differences of opinion. And so first I wanted to give a quick review of some of the things that we're going to miss today, and that we may be able to write more about at ARC. Eric Effern was, I worked with Eric at Windtest in Grevenbroich, Germany. They have the largest land-based wind turbine test site in the world. They can put about 6 good-sized turbines, not offshore turbines, but pretty good-sized land-based turbines at their facility. And wind turbine manufacturers actually will install their turbines there, their new models there, and they will test them and create the power curve at various wind speeds. They have a second group of experts that deal with structural load and blade loads, another group with sound emissions, and a fourth group on grid connectivity. So basically, this outfit here, Windtest, they are very, very good at Met towers, at measurement of wind speeds with accuracy using LiDAR, SODAR, as well as the traditional 3-cup anemometers. So, excuse me, let's go back. So this is also one slide from Tom Pierpoint's presentation. It's kind of interesting, you probably saw it even on the news. Every news station is saying, well, this big storm down in Texas and throughout the Midwest right now, is that caused by climate change? And actually, it was kind of interesting. Tom's slide here kind of answers that question. And the basic answer is no individual event could be directly attributed to climate change. You couldn't say that this wasn't outside of the natural variation of the way the world would have been, before the Industrial Revolution, for example. But what does give a pretty incriminating evidence is that the number of events that are shattering records is astronomical. The year 2020 set new annual records of 22 events, shattering 16 events that occurred not that long ago. And so it's pretty clear that a large number of disaster events have been occurring. We've certainly seen the wildfires in California. If that's not a motivation for a new microgrid, I bet there's an awful lot of people that have put generators in and, to keep their businesses, restaurants, gas stations, whatever, running. Also, we've certainly seen no shortage of hurricanes and bad weather in the South, causing a great deal of trouble. The entire electric grid in Puerto Rico was pretty devastated. And so definitely we see some weather events there. And so the basic answer is it's not completely clear this particular storm was a problem, was caused by climate change, but collectively, climate change is having a big impact and a big cost. So if we're going to talk about the future electric grid, I suppose we could ask how far in the future we go, but also how far back we went. Really, humans have been around for 300,000 years. We've pretty much got most of our energy from fire. Eventually, we figured out that animals like horses and oxen could do a lot of work for us, and they became very convenient. But when the Industrial Revolution came, the steam engine and various other heat engines powered by fossil fuels gave us some real relief and free time and became a very, very valuable thing. And obviously, we've used those fossil-powered resources to power our current electric grid, and they still are. In the history of mankind, electricity is a relatively current thing. We've only had electricity for a little over 100 years. Obviously, electric grids are changing. They're changing very fast now. It's a very disruptive situation, and we'll talk more about that. But you might ask, what electric grids will be like just even in 10 years or 30 years or much longer term. Where are we going to go long term, 150 years from now? And to a large extent, we don't have a unified idea of where we want to go. And in terms of what we really want to power our electric grids in the longer term future. So, one of the problems we have is, CO2 has been quite a problem for quite some time. We've been watching the CO2 build up in the atmosphere from some 250 parts per million to, I think, in the range of 420 parts per million today. Sorry, I'm not quite sure what I have automatic advancing. But, we've basically known there's an elephant in the room for quite some time, and we know there's a lot of generation options, and we know that the problems are very substantial. Currently, you ask, well, where's all that CO2 coming from? Well, right now, China makes 28% of it. The United States makes 14%. But you ask China why they're producing so much, and they said they need their share to develop their economy. The United States has already been putting CO2 in for a much longer period, perhaps put even more CO2 in the atmosphere, came from the US than came from China historically. But both China and the US are actively trying to move away from CO2. China actually makes more renewable energy than the next 5 countries in the world combined. China is also very active in so many areas that it's very, very impressive. But if we want to look at the scope of the problem of how we could change our whole energy system and how electricity fits into that, this graph is very interesting from Lawrence Livermore Laboratory. And it shows all the sources of energy on the left-hand side. And you can see that there's an awful lot of fire-related items, fossil fuel, all right? I mean, we have natural gas, coal, biomass, and petroleum are the bulk ones. And you can even argue that nuclear is a form of fire that goes to a heat engine, also a Rankine cycle engine, much the same way we generate power from coal. Solar, hydro, wind, and geothermal are more direct. But if we're really going to displace all of our loads toward the right-hand side there for transportation, industrial, commercial, and residential with electric power, we have got an awful long way to go. And you can see that the amount of electricity that we will need to generate will be much, much higher. Electric powered devices generally are much more efficient, so there will be a lot less rejected energy. But to change our transportation industry and electrify that, it's a big problem. These, vehicles last 12 years. Houses last much longer. A significant source of carbon dioxide is cement and steel. And there are some technologies that you can make cement and steel with electricity. But you can just see the scope of the problem, I think, in this chart, just where we are and how little we've done so far, to deal with, let's call it the elephant in the room. Of course, one of the things that's kind of useful is this little simulator called the En-ROADS simulator, developed by a group at MIT. It's constantly being upgraded. And basically, it gives you these 18 different variables that you could adjust. So you can go to this website and look it up on the internet, En-ROADS, and you can come up with your own solution and see how you can keep the global temperature from exceeding 2 degrees by 2100. And you could pick what combination of things you might want to do. To some extent, our survey is asking you which combination of some of these things you want to do, at least on the generation side. Very interesting to see this. Um, and of course, one of the other issues is that electricity growth is just happening in general. Basically, almost 90% of the whole electric grid is electrified. And you may not have noticed State Grid and what they've done in the past 10 years. State Grid is just become an enormous level of expansion. They have the largest, most sophisticated electric grid in the world. They have million-volt DC transmission. They have built substations. They have a few problems operating this system, and they're still expanding, but they're doubling down on high voltage DC to get higher reliability. And I found that this statistic was particularly interesting. You can see that China, all right, today generates more power than the United States and EU 27 countries combined, all right? Yet back in 2010, on the right-hand side, they were just starting to catch up with the US, but within 10 years, the US load has actually been flat, even slightly down according to this. I don't have the latest to 2021, but nevertheless, what you see is tremendous expansion in China and tremendous expansion also in India. These places are growing, but the United States and Europe, very flat, in part because we've had energy efficiency. We've had LED light bulbs. We've had more efficient appliances. We've had more efficient, well, cars are probably not electric, but in any event, that's a big deal. Grid storage is one of the big unsolved problems, and exactly how we're going to solve this problem, it's not quite clear. As we've moved away from coal-fired plants and even, flat on nuclear power, we've got less spinning reserves on the network, on the electric networks. And therefore, issues like frequency control are suddenly being picked up by lithium-ion batteries. I think it was, there were some US utilities that basically proved that lithium-ion batteries are fully capable of frequency control. But lithium-ion batteries are great for a few hours, but they're nowhere near the capacity of CAES, compressed air energy storage, or pumped hydro. Some of these large pumped hydro systems, but even the pumped hydro can't shift loads seasonally. We can't take all that solar energy from the summer and move it to the winter where we would need it here in New England. As a light commissioner in our town, if you could try to imagine, how could our town ever get to be 100% renewable power? We do have 2 wind turbines that can provide 20% of our power in town. But even at times, that makes more power than our entire town uses occasionally. If we added enough solar on average for our yearly consumption, we would have this huge problem, and we would need to find an entity that could store that solar power we make in the summer and give it back to us in the winter or when it's not windy or sunny. And days like today, where maybe all the solar panels are covered with snow. So lithium is another really interesting problem. China has the equivalent of 93 gigafactories for lithium batteries. The US has the equivalent of 4, mostly from Tesla. Europe does have the European Battery Alliance plan to build 10, but clearly this is kind of a big international competition of who is going to own. It's not just where the lithium came from, it's more who can actually put together all of those batteries that the world is going to need. The number of batteries that are going to be needed is enormous. And it's pretty clear that lithium batteries will dominate. Solid state batteries will be a niche player for various reasons. So on the horizon, 5 to 10 years, lithium batteries will be $50 per kilowatt hour. Iron and copper will replace these more rare cobalt and nickel. We'll figure out how to put silicon into the anodes to replace the graphite, much higher efficiency, much better weight. It starts to approach the efficiency of these new solid state batteries that we saw from some breakthroughs from the company called QuantumScape. These batteries will have a life cycle of 10,000 cycles, 1,000,000 miles, a calendar life of 30 years. The charging rate, well over 350 kilowatts. There's chargers out there at this rate already. And so these are the situations that are happening. This will make electric vehicles cheaper and compelling. And I can tell you that electric vehicles are very compelling. There might be one exception. This Changli vehicle here, you can buy it for $930. All right, you just order it from Alibaba. They bring it to your house and deliver it in a box. All right, it is a little extra. You have to go to $1,200 if you want the battery. All right. And actually it comes with a rear facing camera, no extra cost. Amazing. And in some situations, it still provides you shelter and provides you the functions of being able to go to the doctors, go to the grocery store, and haul a few things around. It is pitifully slow and terribly engineered, but it certainly is cheap. So what is the future grid going to look like? It's going to look like more power to electrify all of our transports and buildings. You could see that from the Lawrence Livermore laboratory chart that you're going to need a whole lot more power. On the one hand, that's a great opportunity for electric grids to have growth. It's not quite so good for the coal industry or oil refining industry, although in many cases those things are still needed. Oil doesn't go away anytime soon. The vertically integrated central station power, perhaps if nuclear makes a comeback, you could argue that would be the case. But distributed generation with many smaller, mini, micro, nano grids with solar, wind, and batteries and other storage mechanisms, they will play a role, certainly. How much? New grid control based on market structures to create the EPRI vision of the IEN, Integrated Energy Network, and other visions. Really, this was the vision of the smart grid that we didn't ever get, all right? At least not the way it was envisioned. However, keep your eye on a couple of these orders. The FERC 741 order basically enables grid scale batteries. The new FERC order 2222 that was issued in September 2020 will take the US investor-owned utilities or the grid operators some time to create the market rules for this, but this basically would allow individual entities to start participating in the electric grid. This may very well enable finally the grid interactive home. We also could go a long way by interconnecting our whole continent. We have 3 isolated grids. We would love to be able to push some power down to Texas right now and help them with their system, but we have no connection to Texas to do that. Increased energy efficiency and electric efficiency obviously goes without saying. That's surely part of the equation. So we're talking about reinventing fire. That was one of the books. I actually have a copy here of Amory Lovins from the Rocky Mountain Institute. It's kind of a well put, because we've basically got our energy from fire for such a long time, and currently we get a lot of energy from fire. One of the interesting comments, though, that I've seen recently, Bill Gates actually gave a comment like this. He said, solving the COVID-19 problem is relatively easy compared to solving climate change. We actually have a strategy. We have vaccines coming out. We have masks. We have hygiene. We can see success down the road within a year. There's no such optimism for solving climate change. Without major disruptive changes by 2100, more people will die from climate change each year than are dying from COVID-19 today. It is a big, serious problem. And it's a kind of problem that's very easy to kick down the road, which we've been doing. So reinventing our energy systems will change all aspects of human life, because it affects food and farming and industry. Obviously, steel and concrete, is our big energy consumers. It'll affect mining. We'll be mining for different things. Lithium is a very complicated material to mine. There's no shortage of lithium per se, but there's shortage of mining capacity and shortage of battery manufacturing capacity today. Obviously, it affects transportation, logistics, housing, and it will take all kinds of skills to solve this problem. So just to kind of leave you with a couple of thoughts, one of the things that I think will enable, as an owner of an electric car, I really wanted to have an electric vehicle that had vehicle to grid. And none of the electric cars being sold in the US today are equipped with vehicle to grid. The very first Teslas had vehicle to grid, but nobody used it. And also, it's not quite so useful to me to have vehicle to grid unless I could get compensated for pushing power back into the grid, all right? Or compensated for conserving power and saving more for other people that really desperately need it. If I had a vehicle to grid with say a Tesla Model 3, I could power for 4 days my house. Any event, here it is. I could power it from solar panels. I could be independent. I could export power to Texas and give them a hand. Any event, that's what I have to go. And thank you for your attention. And I'm going to turn the presentation over to Christopher Castro, who can share his screen now. Thank you.
Thank you, Rick. And I'm trying to start my video. It looks like you all have stopped that as the host. And then let me start to share my screen here. Perfect.
Right. You should be able, okay, very good.
Good to go. Give me a quick second here. Okay, hopefully you all can see that full screen.
Looks good.
Okay, all right. Well, Rick, thank you so much for the opportunity to come and speak to you all and for all of the attendees today. My name is Chris Castro. I'm here at the City of Orlando. I serve as our mayor, Buddy Dyer's senior advisor on all things climate, sustainability, and resilience. I direct the Office of Sustainability and Resilience and have been instrumental in pulling together also our future-ready master plan and roadmap, which is really our Smart Cities initiative at the City of Orlando. Today, I plan on taking kind of the framework that Rick just walked us through at a pretty high level and dive deeper into how cities are beginning to prepare for the future of the electric grid and how we're collaborating with our utility on different programming, different policies, and partnerships, quite frankly, to really accelerate this work and the vision of that future, cleaner, healthier, more resilient electric grid. Most people don't, have heard of Orlando, I assume. We're one of the best name brands in the world. And one thing to realize is that Orlando is one of the fastest growing cities in the country, even pre and post COVID. And we're still seeing roughly about 1,000 people moving to the Orlando region every single week. In addition to our tourism numbers. Pre-COVID, we were the most visited city in America, over 75 million visitors per year. And even post-COVID, we've seen some of that come back in a safe way. And so we're still really focused on being a city that's at the forefront of innovation and sustainability and have a lot going on in that respect. So our program, in thinking through this, really launched back in 2007. Our mayor, Buddy Dyer, launched what's called Greenworks Orlando. And the initiative was essentially to transform our city into one of the most environmentally friendly, socially equitable and inclusive, and economically vibrant city in the country, in America. And when you think about that quote directly from our mayor, it really centers in what we often call the triple bottom line of sustainability. It touches on people, planet, and our collective prosperity. And I think that's really important in how Orlando looks at this concept of sustainability and resilience, and that it's very comprehensive and very holistic. Our program, Greenworks, has these 7 key focused areas that we prioritize to achieve urban sustainability. And today's presentation, I'll touch on 3 of them: clean energy, green buildings, and electric and alternative transportation, all which play a pretty significant role in the future of our electric grid. Other important thing I want to mention, and I think it's critical, is that cities, businesses, institutions begin to work at weaving in the global framework for sustainable development into our local priorities. And Orlando is one of the vanguard cities working on integrating the Sustainable Development Goals, or also known as the SDGs, into our work at the local priorities. And we've even established regional capacity with our regional planning council, with our universities, with our county government, to really center these 17 goals as part of our response and recovery to this global pandemic that we're in. And I'll tell you, I'm part of a cohort of cities globally in every single continent on the planet. And we are collaborating and working together to really center moving us forward. And as you can see, there are many goals that tie into the future of the electric grid, one being goal number 7, advancing affordable and clean energy. Obviously, the focus around decent work and economic growth and sustainable cities and communities are just a few that really touch in on this. But as you are probably aware, many of these tie into the electric grid concept, even the energy water nexus as an example. So in terms of our pathway and how we go about developing goals and strategies, Orlando approaches this very much from a co-creation standpoint. Anytime we go about developing a municipal or citywide plan, we very much center our community first, the stakeholders that would be impacted, as well as engaging our own departments and divisions. And here's a snapshot of some of the core plans that weave in the transition of the electric grid into our strategies, everything from our municipal operations plan and how we operate as a city government, to our climate vulnerability and risk assessment, looking at the risks to the electric grid, our greenhouse gas emissions inventory, our community action plan for sustainability, and a couple of others, Division Zero and Future Ready. So within each one of these, we realize the importance around being proactive in planning for this transition. And the other thing that's important before I dive into specifics is that all of this is really data driven. We often hear the slogan, you can't manage what you don't measure. And we certainly use data to help drive our policymaking process and development of our priorities. This is a snapshot of the greenhouse gas emissions footprint of the city of Orlando over the course of the last decade plus. And you can see since we launched Greenworks in 2007, we've been tracking at a pretty consistent basis in terms of where the emissions profile is coming from, and actually seeing a reduction in overall CO2e from our city. We've seen about 19% reduction overall since 2007, and almost double that from a per capita standpoint. So we are beginning to see good trends in terms of our economy continuing to grow as we decouple emissions intensity and carbon output. But we're, quite frankly, that curve of reduction isn't as steep as we need it to be in order to even achieve our own goals, let alone the global goals for climate. So diving in, and the first topic I wanted to talk about is green buildings, and there's a big movement around grid interactive efficient buildings. In fact, there's a new term, GEBS, that the Department of Energy launched last year, and there's funding behind it to begin looking at how buildings interact closely with the electric grid, and how they become, quite frankly, an asset as part of the grid in providing opportunities for peak demand shaving, as you know, on-site generation, and other forms of interaction with the grid. So from our perspective, one thing that we've focused on is ensuring that for the city buildings that we own and occupy, that we go above and beyond the Florida Building Code. I often call that the worst building to build by law, because technically you can't build anything worse than what the code says. And so we have realized that in looking at the total cost of ownership for our facilities, it actually makes very good fiscal sense, financial sense, for us to build to a high-performing, efficient, interactive building standard. And that's because obviously only about 25% of the cost of a building is burdened upon the construction. 75% is often the ongoing operation and maintenance of that facility over time. And if we're cutting ourselves short to build, again, the Florida Building Code building and not going above and beyond, we're going to be burdening our own taxpayers with investing in operating these inefficient buildings. So for us, we've set a standard that every new construction project that the city owns and operates will be a mandatory LEED Silver. We've actually taken the LEED scorecard, and about a third of the points have been prescribed in terms of required points that they need to achieve. And we have really gone above and beyond, not just with your office buildings, but all types of facilities, fire stations, major venues like the Amway Center and soccer stadiums that you see there, our Performing Arts Center, the community centers, and more. And I think that's really important that we're really trying to move the needle on that. In addition, we are just ending about a $20 million municipal green bond that we decided to self-perform. Many of you all are aware of the model around energy savings performance contracts, or ESPCs, where we bring in an ESCO, energy service company, to help do these retrofits and split the savings over a long term. Instead, we decided to actually self-perform these building retrofits, taking out very low cost of capital from the bond market for cities, and essentially procuring those assets, whether it's lighting or HVAC equipment, and then hiring continuing contractors to install them and use dashboards to measure and verify those savings. This snapshot here is of the Lucid Building OS dashboard that we use. It takes about 5,000 meters every single month, and it helps populate, and in fact, down to 15-minute intervals, we're able to to see how these buildings are performing and catch anomalies and be able to improve efficiency over time. And I think that's where we're going to start to see more of. And then cities are also starting to question, how can we encourage the private sector real estate market to also see the opportunity that is presented regarding energy efficiency and high performance buildings. And one of the policies that is beginning to gain a lot of traction around the country is a building benchmarking, energy audits, and transparency policy. This, in a nutshell, requires buildings above a certain size threshold, for us it's 50,000 gross square footage, to essentially step on the scale and perform an annual energy benchmark. And that benchmark is like a miles per gallon, right? Using the Energy Star Portfolio Manager tool, you plug in building characteristics, you plug in the utility bills and other data that is requested. And then the tool basically scores the building from 1 to 100, 100 being the best in class, Energy Star, 1 being the worst in class, 50 being the national average for that type of building, year built, and other characteristics. And the idea is that, back to you can't manage what you don't measure, if our building owners and real estate community don't understand that their performance has impact on public health and the environment, and that there is money to literally be made for themselves if they invest and retrofit those buildings, then we're really not going to move the needle. We're not going to create a market transformation for energy efficiency. And that's what we're about. We're about market transformation towards clean energy. So we now have this policy, and in fact, year over year since 2018, buildings, about 1,000 buildings around the city have been required to submit their information. We now have an open data website where we publish this map that you see here, and people can zoom in and analyze different buildings, compare them to each other. And in addition, we're about to publish our first impact report from this policy. And it's been eye-opening to see some of the analytics and the data that we're able to realize in terms of what we're capturing. So really interesting information. So that's a little bit about kind of what we're doing on the building side. Now let's transition to how we're approaching the actual transition of the grid. And in Orlando, we are fortunate that we have a municipal electric and water utility known as OUC, Orlando Utilities Commission. And of course, having a relationship with the municipal utility lends itself to be a little bit more flexible and innovative in our business models and how we make this transition to the future of the electric grid that we're talking about today. OUC has a pretty healthy mix of different fuel types, as you can see here, very diverse and a very fast-growing portfolio. And in 2017, the city put a stake in the ground, and our mayor and city council passed policy that essentially commits the city to transitioning 100% of our municipal operations to be powered by renewables by 2030, and then citywide to transition our entire electric grid to be powered by renewables by 2050. So this has been our goal, and the challenge has been that there's many cities, in fact, almost 200 plus cities now around the country that have made similar commitments. Let's move our community to a renewables future, but often those cities aren't in the driver's seat to make that decision. Neither is Orlando, even if we own our own municipal utility. There are different regulations and oversight that the utility has that the city doesn't, right? So we've set policy to set the vision of where we want it to go. And over the course of the last 18 months, I sat on the advisory board for the utility to develop our most recent energy integrated resource plan. The IRP effort, as many of you all know, is the scenario planning exercise to determine how we're going to transition to the future of the electric grid. And what's fascinating is in December, we just published this just a couple of months ago, and OUC came out with some incredible commitments, I think, that many utilities hopefully can emulate. One is that we've committed to science-based targets in reducing carbon emissions and achieving net zero carbon by 2050, with intermediate CO2 reduction targets 50% in 2030, 75% in 2040. In addition, we currently still own and operate coal-fired generation. And in fact, they're pretty young fleets in the grand scheme of things. The first one was built in 1989. The second one came online in 1996. And as you can imagine, those plants can operate for probably at least another 30 years. And what's fascinating is because of this EIRP and our commitment to sustainability, our utility came out saying that we will end coal-fired generation by 2027 at the latest, and a drastic reduction of coal use in 2025. So trends that we're seeing across the country is decarbonization is definitely driving us forward. And we're beginning to see that just based on economics, renewables are becoming price competitive without state subsidies. In Florida, we don't have any state subsidies, and we're seeing parity. So it's quite fascinating. And as you can see there on the chart, little by little, we're going to continue to ramp up our renewables, our energy storage, and our energy efficiency solutions to get to that goal. Now, as a city, we've started to work with Google, Project Sunroof, with a group called GreenLink Analytics, and we've now mapped the entire city of Orlando, every single rooftop, and using this tool, identified the amount of rooftop capacity just on rooftops of buildings that we have to meet our energy needs. And what we identified is 92% of rooftops in Orlando are suitable, get enough solar irradiance to make the economics work to land solar. And in addition to that, a capacity of close to 2 gigawatts. Now, Orlando powers itself right now at right around a peak load of 1.2, 1.3 gigawatts. And yes, we know that solar is a variable resource. It has a lower capacity factor, around 25 to 30%. And so you need 3, sometimes 4 times as much capacity to meet the load. But long story short, just on rooftops, we're talking about half of that capacity almost being met. And that's amazing. That's not floating solar. That's not carport canopies. That's not utility scale. So that was a short little, clip that we just published of last year's rooftop solar install. So even during COVID, we moved forward very aggressively with a lot of our renewables efforts, and I'll show you a larger utility farm here shortly. But those were 4 new rooftop solar projects on fire stations around the city. We're working now on an additional 7 facilities this calendar year. And the one in front of you is at our fleet and facilities complex, our maintenance complex. You can see a 420 kW rooftop system already that's been there for some time. And now we're in the process of developing a carport solar canopy to shade our vehicles and create an electric vehicle lot. There will be 36 parking spaces dedicated to EVs under this carport. And we are working on a V2G capability so that we can begin to test, to Rick's point, how our vehicles can be moving batteries, moving power plants in case of a disaster, where we can roll up one of our vehicles to a neighborhood center or the like. We are also helping our residents to install more rooftop solar, and we're doing so through a creative solar cooperative, solar co-op models. There's a great nonprofit, if you hadn't heard of them, Solar United Neighbors, also known as SUN. And this organization helps to create these cooperatives in a community where homeowners bundle their demand together to go rooftop solar. They collectively go out to the market for contractors, and the contractors come back with preferred pricing because they're able to achieve an economies of scale that normally they can't achieve with one-offs, right? And so if 100 homeowners or 200 homeowners go solar together, or at least bundle their demand together, you can lock in a preferred price point. And over just the last year and a half, we've had over 1.5 megawatts of rooftop solar installed through this model and facilitated through the city. We talked about some of the utility solar farms. I think you're starting to see more of this around the country, especially in Florida. Even our investor-owned utilities like FPL, Duke Energy, TECO are going gangbusters on landing utility scale solar. And I often tell people, they're not doing it to save the planet, quite frankly. They're doing it because it's the cheapest form of new power generation today. And it will continue to be cheaper, right? It's a deflationary energy source, not an inflationary energy source, meaning it gets cheaper over time. Unlike fossil fuels, inflationary, that gets more expensive over time, right? We got the easy stuff. Now we're starting to go further and further out and deeper down to get the same resource, which makes it more expensive. So we're starting to really see that change happen. And this is our most recent 108 megawatt solar farm that we brought online summer of this past year, so summer of 2020 during COVID. This one is here in Orlando, and it's one of several utility scale solar farms that we have now up and running, helping to power our community. And then in terms of unique applications, I think one of the areas that we're starting to see innovation is photovoltaics or floating solar. In Orlando, we joke that it's kind of like an Atlantis in reverse. There are so many water bodies. There are 6,000 man-made retention ponds. These are not spring-fed lakes. They're not natural lakes. They are holes that we create so that when rain happens, it goes into a stormwater pond. And as a result, there isn't a lot of value other than holding that stormwater. And we've started now regionally to look at this as a real asset. NREL has a fantastic study, the National Renewable Energy Lab, that shows that about 10% of the United States electricity demand could be met off of floating solar using water reservoirs that are certified and published. Now, retention ponds are not in the water reservoir database, so we're not even touching all of the water bodies, just the ones that are registered. So there's a huge potential. We've started to land over a megawatt here in the region, this most recent one at the Orlando International Airport, in the shape of course, the Orlando International Airport logo. So the next time you fly into Orlando International and you go onto our autonomous trams and you feel like you're in a future-ready city, well, you got to look outside when you're on that tram, because you'll see also this unique application of solar. And this is starting to be scaled all around. I thought it would also be important to share that we are testing unique ways of capturing carbon as well. And one of the grants that were received a few years ago by OUC was carbon capture and utilization, using algae to sequester point source emissions from the power plant and grow the next generation of the bioeconomy. There's so many products that algae can turn into. I did my dissertation in undergrad on this topic of microalgae and biofuels, and it's just fascinating. And I think one of the last areas around the electric grid is this storage component. And we've started to test lithium ion, to Rick's point, at distributed scales. But just this past year, we're awarded a pretty large H2 at scale grant, and now testing green hydrogen. So we have a floating solar array basically powering a plug power electrolyzer that's creating hydrogen, storing those in the 1H2 tanks that you see there. And then that goes into fuel cells that helps us to drive electricity generation during intermittent times of solar generation, right? New cloud cover comes over, or afternoon storm, you could ramp up green hydrogen and help to true that up. My last topic, and I know I'm running short of time here, is quick. It's transportation. And I do think that EVs are going to play a pretty significant role in the future of our electric grid. As Rick talked about, we've actually seen a decline of the overall electricity consumption in the country, but utilities are really starting to focus on electric vehicles. That's the saving grace to bring the load back up and to drive more electricity demand, quite frankly. So in Orlando, we've started to work on projections and worked with NREL to project out what vehicle sales and adoptions might be. And we're looking at basically more than doubling the amount of EVs on the road between now and 2025. So we have a pretty steep growth. We're doing a lot with our municipal fleet. We even have electric motorcycles that we're testing. We just finished a pilot with the Arcimoto 3-wheeled electric vehicle for city operations. And we've started to roll out a pretty good amount of new EVs per year using the EV Purchasing Collaborative through the climate mayors. Similar to that solar co-op, they actually bundled the demand of hundreds of cities that want EVs, and they went to the market and they found reduced price points for everyone who's part of that collaborative. So pretty cool model. We're doing a lot with expanding EVSE and charging stations around the region. We have over 500 ports within Orange County alone, and I'm almost done with a project I've been working on for about a year to land another 100 level 2s around the entire city at parks, neighborhood centers, parking garages, flat lots, on-street parking. I mean, we are putting them all over the place, and they're doubling as a resource for our city fleet, which we're transitioning to EVs, but also, of course, as an amenity to our residents that drive electric vehicles as well. And then, of course, the DC fast charging hubs We were awarded a VW settlement funding, and in partnership with OUC, we're going to be landing the first DC fast charging hub in the city, right in downtown Orlando, right off of I-4. And one of the things we have to start to think about, especially for Floridians, is emergency evacuation once we're all in electric vehicles, or a lot of us are, right? Think about the next Dorian hurricane coming at us, and massive category 4, category 5, when we're getting evacuated and people are in EVs, we got to figure out a very efficient way for people to safely get out of the state. And DC fast charging hubs near these emergency evacuation routes is one way we're going to do that. So luckily our state is starting to think about that. We just published an EV roadmap for the state to look at those areas and gaps, and funding is going to persist. The last topic I have is around transitioning our bus fleet. And so we're doing a lot to work with our transit authority on e-buses and electrifying transit. Our goal is basically 100% of our buses to be electric and alternative fuel by 2030, electric or alternative fuel by 2030. So the first round of e-buses, 14 of them went into operations just this past October. And here's just a quick little short video on that. So that's what I have for you all today. I really appreciate you all listening in, and I look forward to diving into any questions that you have. And with that, Rick, I'll turn it back to you.
All right, great. I would ask all of our participants, panelists, to start their cameras and participate with this next part of the presentation. While we're waiting for anybody else to take the Menti survey that we have, I just wanted to take this time to let both Chuck Newton and Jet Winter introduce themselves and their backgrounds. Jet, why don't you go first?
Yeah, hi everybody. Thank you, Rick. This is Jet Winter, and I'm the commercial lead at GE for grid analytics software. I've been in the field for over 10 years and focused specifically on the T&D space. So a lot of you folks are, have been my customers or are my customers in sort of the analytics arena.
Great. And Chuck, go ahead, introduce yourself. We know you've got quite a bit of utility experience.
Sure. Well, Newton Evans Research Company began business in 1978. We began studying the electrical world in 1984. And for the past 37 years now, we've been at it, trying to actually position where utilities really are, and are we moving ahead, taking advantage, like the city of Orlando. Just amazing. That is incredible. And I hope all American cities and towns will be able to join you. You're up in the lead with Austin, Nashville, and San Antonio. A few other municipally operated utilities run cities, and it makes a big difference. So IOUs, however, are extremely important. 2/3 of our nation's electricity supply, 2/3 of our customers are via the investor-owned utility community. But that still leaves a third with 1,700 munis and 900 plus co-ops. Florida is a very strong state for co-ops, all very important, all trying to modernize, all the different methods, procedures, funding resources, and staffing available to do that. So at any rate, we try to measure progress year to year, decade to decade, on just how our utility world is transitioning into what we need it to be for a livable, great future for us and for the whole world, actually. So we've got a mature electrical economy. Other countries and developing nations can sort of leapfrog us and move right into a more modern era as they move into electrical infrastructure. They don't need to take along 100 years of baggage, so to speak, with them. But in the meantime, we are ramping up the skill set for our equipment, the need for analytics software certainly at the top of what we see as being requirements for us to move forward.
Great. I think I probably should give a lot more credit to Christopher, just how impressive the work he's doing there. You know, it would seem to me an awful lot of cities need to have sustainability and resilience as part of their infrastructure. That's a new job position that didn't exist just a few years ago.
Yeah,
absolutely.
Definitely. Thank you, Rick. Thank you, Chuck. Appreciate that. And you know, believe it or not, there's actually a lot of good progress happening in cities around the country. I'm part of several different peer networks, and the momentum that's been happening the last 4 years in this space is impressive. And there's no doubt that you know, we're kind of on the bleeding edge of thinking innovatively about how to make it a reality. But the good news is there is good work happening coast to coast, up and down the coastlines, and I think you know, it's important that we don't forget how critical cities are in moving us towards that future, right?
Yes, absolutely. And you know, we're a muni town as well. The munis have the opportunity of being very creative. We can do much more creative things than the investor-owned utilities can. But we still have that cost, reliability, and environmental compliance issues to deal with that we've always had. So let's take a look at the result of this survey. And as I kind of predicted, there's a kind of a wide range of answers here. This is not at all a consensus here, all right? In fact, I'm going to ask you guys to participate. I mean, on the first one, commercial scale wind. Boy, look at that. There's a few people say it's great. A few people say, you know, we know that it's not going to be that important. Now, this was by 2050, all right? So imagine that we don't have a substantial amount of wind by 2050. I wonder where people were thinking when they were voting down on the 25% importance for wind, for solar or wind, all right? Because they're both spread all over the place as if they came in groups. Chuck, any comments? This is a, you know, we have a more educated than typical audience listening to here. You know, we are an industrial audience. You can see, as I mentioned, that there is not a consensus on how we're going to generate power in the future.
You know, there is not, but if you look at the trends, clearly the renewables portion is strong. And what I see is the complement to renewables is BESS, or bulk energy storage systems. It's certainly a go together. It is going to be an absolute requirement to have bulk energy storage located all along the food chain for electricity supply, from the generating plants to transmission subs, distribution subs, outside our buildings and homes. I really believe that, just scalable energy storage devices. And to Chris's point earlier, you know, if we all go to electric vehicles and there's a big emergency and it takes an hour, even under fast charging today, to let's say an hour worth of charging in a fast charger, I believe, Chris, you probably know this better than me, but I think it's 160 miles of travel that you're able to get for 1 hour of fast charging, something on that scale.
In that range, sure.
In that range, yeah. So, you know, I think those will also eventually get faster as well and become even more efficient. But that's not bad. If you had something like that in your home, overnight charging, you're going to have a full day's worth of mileage available to your car.
So as an EV owner, the Tesla superchargers I go to today, they start charging it at 150 kilowatts, which is about 600 miles of range per hour. All right. And that's not that's only the 120. That's actually 120 kilowatts. They have
up to 300.
They have charging over 300. So, and this is and as batteries get better, the limit can be bigger, you know? So Jet, your comment on these future generation assets, you're going to be managing all these assets, right? You got software to manage every kind of asset, right? Solar panels, you know, transformers, you know, wires, poles. You can monitor all this stuff. You know, how do you see the challenges of this, and where does GE fit into monitoring all this stuff?
Sure, good. Thank you, Rick. Yeah, so a couple of comments here. First of all, so I work with T&D utilities globally, and right now on the renewable side, we really see wind as a sort of predominant sort of industrial level resource that's being used more so than solar. Now, again, based on this study, it looks like solar will catch up. And I think that if we think about how GE fits in and how software plays a role, with these different sources of generation, you begin to introduce instability into the grid. And this is something that a lot of people don't understand. They do understand the nirvana of renewables being cleaner and, lower carbon footprint and, eliminating a lot of the climate change issues. But the instability that can occur in the grid can be quite dramatic. And so a lot of the things that we do at GE are a lot of very fast measurements in order to identify things like inertia and so on that you need to keep at certain levels as these renewables come in and out as far as being available and not available. So I think there's a whole data capture, a data management, a data analytics component at very, very big scale that needs to happen. The utility energy industry is actually one of the most data intensive industries in the world. A lot of people don't realize that. They think the stock market, blah, blah. It's this industry, so much data, so many more things are being measured and metered today. It's mind-boggling, the tsunami of data coming at us. And we think really that's the key, is being able to handle, manage, provide insights back to the operators, like Chris and his team, in order to run a more effective grid. So that's kind of a little bit of how we, our vision at a very high level.
Yeah, we saw a guy from Larry's presentation earlier today that was talking about some of the smart city things, a guy from Helsinki, and he was showing some three-dimensional models of what goes on. And we know that the geographical information systems, GIS systems that can monitor the grid, they can go right down to a homeowner smart meter and zoom all the way out to the state, to the region, to the whole range. Amazing. So Christopher,
Yep.
You see all of these things, obviously you're pretty sunny down there in Florida. You don't have quite as much wind down there. We have a lot of wind up here. We could power from offshore wind in New England. We could power 20 times our current rate of consumption. We just need to hook high voltage DC up to Quebec Hydro's 35 gigawatts of storage and use them as our battery. But so how do you see some of the generation system? You have nuclear in Florida, you have a lot of solar. I don't know if you have a whole lot of wind though.
That's correct, Rick. We don't have a lot of commercial scale wind. There is a lot of feasibility studies going on in terms of offshore wind on the coast of Florida. But you can imagine with intense extreme weather events, how those will withstand large hurricanes like that. And so that is a concern. There's also a lot of good wind profile in the Gulf where you have, old oil and gas rigs that could be converted over to wind turbines. And there is some of that happening in other parts of the world we see opportunity with. Some of the stats that I see here, and you just brought up a really important one, Rick, and that is the importance of DC high voltage transmission corridors. In Florida, as an example, a recent study that I showed, we have less than 4 gigawatts of capacity that we could import from out of the state of Florida. See, Florida is a peninsula, so we're very vulnerable, unlike most of the entire country, with its ability to pull from different grids in different states. We're very, very vulnerable. So we're only able to pull north of us, and what's available there is about 4 gigs, and that's about the capacity already being used. So if we're talking about taking wind from the Northwest to bring down here into Orlando, which we do have in our IRP plan, we need to prioritize investing in DC high voltage transmission. And I think that's going to be critical. And it looks like our audience also realizes the importance of that investment. The other thing I see here is demand response and grid interactive buildings and homes like we talked about. I think more and more we're going to start to look at how our homes and a lot of the smart appliances, whether it's your hybrid heat pump water heater, whether it's your smart washer and dryers, whether it's your HVAC and smart thermostat, are going to be controllable loads that the utility at certain times could be able to utilize and leverage to minimize demand side resource and therefore maximize the overall grid's efficiency. So we're starting to test some of that out here in Orlando as well, starting with smart thermostats, but evolving into many other type of demand response programs. I was interested in how much people felt nuclear with thorium fuel cell, the molten salt, how they felt that was something even higher than natural gas with CCS. So that's interesting to hear from our participants, and that people feel that that's a poised resource that could really scale. And I do think that nuclear plays a role in our transition. But I don't know at what extent. Like, I think it's important we continue to operate the fleet of nuclear plants that we have in this country as we start to move more variable intermittent resources, to Jet's point. But at a certain extent, nuclear is very costly. It's very expensive. It just doesn't make sense when you look at just the economics of building a new plant. It just doesn't. I mean, look at Vogel and how much more money that plant is versus what they originally estimated. I mean, it's 4 or 5x. So it's a lot, and we need to be realistic about the abilities. Now, these new nuclear reactors are small, modular. They are scalable, and I think different than our large centralized power generation that we often think about. But those are some thoughts.
Yeah, my understanding, I worked on the nuclear industry for a while, and I had a lot of nuclear engineers, very, very big champions of the small modular reactor. However, they did mention that if you look at some of the analysis, that in order to justify the cost of a small modular reactor factory, basically you're going to build reactors in the factory, certify them in the factory, and ship them to the site.
Yes.
However, in order to get that factory up and running, they need to get an order for like 50 SMRs first. And so you're going to have a lot of people cough out an awful lot of money in order to build an SMR reactor, even though there is some preliminary NRC approval of them. So
spot on. Yep.
So I know we are starting to pick up a few questions. I'm going to look in the Q&A. One of the comments was from Dick Slansky, said that he would like to have a little bit more talking about the wide adoptions of EV in the next decade and the ability of the grid to power that generation to meet the electrical requirements in transportation. I know as my own utility, that's part of our long-term plan. We don't quite know what it is, but we know that it's coming. And we know that if everybody comes home with an EV and plugs in at 6 o'clock, we got a problem. All right. We think peak load is a problem now. In the middle of a hot summer day, everybody comes home with their EV. But on the other hand, 270 million electric vehicles with all vehicle to grid that could all be pushing power back into the grid. Wow. Talk about a resource. All right.
Mm-hmm.
Any event, some comments on this. Let's start with Chuck.
Sure. Well, the latest figures I have seen from a report I worked on with DOE just concluded in their quadrennial report to Congress on grid modernization. It's called Smart Grid Systems Report. It should be available to the public within the next 3 months, I'm thinking. But at any rate, one of the factoids that we came up with was that by 2030, there will still only be about 5 million electric vehicles on the road in the US. That's a lot more than now. That's 10 times what we have now. But if the president's indication that all 650,000 federal vehicles will also become electrified over the next decade, that's gonna add another large group to our base of total EV installations by that year, by 2030. So we're going to need more fast chargers. We're going to need a lot, but the two-way flow of electricity may become a reality by that point in time. You see, onto the grid and draw from the grid. So might be able to synchronize those efforts.
Jet, you've mentioned grid stability issues here as well. How do you see the, clearly it's an opportunity for utilities to sell more power, but what do they have to do to accommodate all those EVs?
Well, a couple comments. First of all, there was a recent announcement in California, where I'm based, where they're going to stop selling gas-powered vehicles, I believe, in 2030. So I think what you're going to see is an acceleration in the curve of adoption of EV vehicles. So instead of it being sort of a linear extrapolation, it's actually going to geometrically increase. So again, I'm going to lean a little bit on the analytics side. So everybody plugs in at 6 p.m. Rick, you said that, but there's no reason why the utility needs to actually provide them power right then, because the odds of them going out after they come home and going to stay home for dinner and a relaxing night with family probably fairly low. So what we would argue is let's charge those vehicles over the night. So maybe some sections are charging at 7, some at 8, 9, 10, 11, middle of the night. So you distribute. So that's sort of one component. The other side of it, like Chuck mentioned, which is putting power back onto the grid, again, can be analytics driven, right? Sometimes you don't need the power, sometimes you do. People would need to opt into that program much the same way they do with demand response. Again, we think it's the smart software that really helps drive and optimize that as these enabling technologies become available. But in general, we see EV adoption accelerating at a faster rate than just extrapolating what it's been to date.
Right. In fact, our utility gives our EV owners free chargers managed by ChargePoint with the stipulation that we can shut them off during peak loads. And we use that, we could justify that $600 wall charger, based on peak load adjustment. So Christopher, in Orlando,
Yeah.
how does your OUC utility deal with this EV problem or plan?
Well, we see it as not a problem. We see it as an opportunity. And so there's definitely, in the IRP modeling that we looked at, when we actually looked at the load growth of EVs, it almost matched to the load loss of energy efficiency and distributed generation, right? It almost matched. It was so close that I thought, man, it's almost 1 for 1. And what's interesting is most of the people, at least early on, who are going to be adopting these EVs are often in line with those that adopt rooftop solar as well, right? So in one way, you're losing a customer, and another way, you're adding a customer. It's almost a wash. And we did see that out to the year of 2050 in our modeling for the EIRP. I do think, to the point that all of us are making, that EVs are going to have a pretty steep growth this decade, and that we're going to start to see more dynamic uses of the electric vehicles. We're actually thinking about this for school buses and transit buses that have the ability of rolling up to a community center during an outage because of a hurricane and being able to provide backup reliable power to that. And we're actually retrofitting now neighborhood centers with automatic transfer switches and all of the actuaries and components that it would need to be able to roll up a V2G type vehicle and be able to power these facilities. So we're starting to equip the facilities with the technical specs to make it happen, right? And so definitely, the dynamism is going to be important. The last thing I'll mention is time of use rates. And so utilities are beginning to move from your fixed residential rate towards this time of use rate. We're a little bit behind the times here in Florida, believe it or not, in terms of how we handle utilities markets. But we now have instituted a time of use rate, and we're beginning to look at how we encourage people and incentivize them to be charging on those off-peak forms of hours. Not that we're going to require them to do that yet, but if we do start to hit some of those peak challenges, to your point, Rick, we may have to cut off some of those chargers at certain times. At this point, that's not within our trajectory, and it's really about encouraging the use of electricity in certain times of the day so that we can more flatten that curve and we could help project and estimate the demand that's needed.
So one of the questions that came in is right on this category. It's called, aren't we going to need some advanced communication networks to monitor and coordinate the distribution level resources? Duke Energy was speaking last year in our session, and they basically said, yeah, we put a zillion smart meters in, but no, we really didn't get them to work on anything. And obviously I'll show you right now, that's ISO New England. I can barely see it. That's the price structure in every place in our thing. That real-time prices changes. But as a homeowner, consumer, that means nothing to me. I have fixed meter, not even time of day, but won't meters eventually go to real-time pricing, or will there also be smart circuit breakers in addition to smart meters? So these are all going to have to be communicated and coordinated. What do you think, Jet? GE is right in the middle of all that kind of stuff.
Yeah, I mean, I think the question about networks is a smart one. If you look at a lot of the AMI meters, the networking infrastructure that came with them was fairly lightweight. So it was built to sort of be a cash register that you could now turn off the meter readers. You now had these sort of updates, pricing updates, consumption updates, and some other data. But when you really wanted to do more advanced analytics and so on, you all of a sudden you realize that the bandwidth wasn't there, right? So depending on the network infrastructure. So I think the network piece, which again, we now have 5G now becoming, more and more available, came out as far as iPhone 12. So you're going to see other backhauls that I think are going to increase that ability to capture that data and to operate in much more of a real-time environment. You also have consumers, which is something that I always like to emphasize to my folks that I present to. Their expectations are increasing, right? So it's no longer acceptable to see pricing as it was maybe 3 hours ago, when everything in our world has moved to real time. So I think you'll continue to see a lot of changes, and the networking piece is going to be extremely important, because keep in mind, we're running these distributed grids with distributed infrastructure across many heterogeneous products and by multiple vendors. So that network, I think, is a key piece.
And they call that DERMS, right? The Distributed Energy Resource Management Systems for short. And I do see, more and more on the utility side, the need for us to have sophisticated, platforms like I think what you have, Jet, for us to be able to, more reliably manage that demand load and see it as a load, not necessarily as a, see it as a resource, not just as the load. So that's going to be critical.
And Chuck?
So just to add on to this discussion, there are still, based on the surveys we've conducted over the last decade regarding field communications, there's still this issue of where do I put control? Some utilities want control back at the control center, others at the substation level, because now there's a lot of computing power out there, a lot of decision-making capabilities, especially with products such as GE is developing at all 3 locations. And the 3rd location is down at the customer site. So you put processing power down there, control is truly distributed. Then you need neighborhood area networks feeding into field area networks and then into a wider area high-speed network back to the control center. So a lot of issues, both software-wise and communications-wise, that are in the mix here. And also, another point here is that utilities for the first 100 years had control over their generation assets. That's no longer the case with most renewables now coming on stream, owned by industrials, commercials, and private suppliers. So we need, if we can't have control, we certainly need coordination, and we need a buy-in from these kind of groups.
So our attendee, Marty Horry, asked the question, what is the viability of microgrids for EV charging stations with some redundancy maybe? And I think maybe I'd like to expand that a question, because microgrids that are owned and operated by the utilities are one thing, but microgrids that are privately owned by individual entities, they don't always play well with the utility. So the question is how do microgrids fit in here? Will we have a network of throughout the entire United States, with a whole collection of microgrids that are interacting with a larger grid? How are microgrids really going to unfold going forward?
Well, I'll jump in and say that I do think we're going to start to see more of the micro and even down to a nanoscale, a particular building or a particular home and its ability of controlling its load generation, et cetera. The hydrogen project I mentioned in the presentation is actually a nanogrid pilot that we're doing at one of our utility facilities. And it includes not just the floating solar array, about 64 kW of floating solar, and the electrolyzer and all of that, but it also has 3 EV charging stations with V2G capability. It has 2 vanadium redox flow batteries, which are used for storage and dispatch, and then 2 trailers of the hydrogen tanks that could be mobile actually and taken to another site. And our goal is to essentially figure out how all of these various components can work together to reliably provide all of the energy needs at that particular site. And I do see that scaling to multiple sites, being the microgrid, and connecting to the larger grid. From a resilience standpoint, though, this is important, especially in Florida. As these larger grids get hit and impacted, by possible extreme weather events, the ability of islanding ourselves from that and being able to maintain critical functions is critical. We have, the fire stations, the 911 call centers, the health department, a lot of our neighborhood centers that become houses of refuge during storms. These are critical facilities that need to continue operating in times of disruption or anomaly in the electric grid. And I do see us, more of that growth, nano and microgrids expanding. In our Florida model, though, I think those are going to be owned by the utility. And that just happens to be the way that we regulate electricity in Florida. It's kind of backwards and doesn't allow for independent power providers, to Chuck's point, to play in the field. But I do think in other territories, other parts of the country, we may see independently owned nano and microgrids that do have connectivity to the larger grid and ability of dispatching to and from and islanding themselves from the grid.
So we know that there's a lot of mini grids, like the University of Austin, Texas, is one of the largest microgrids. It's even bigger than a microgrid. It's like 100 megawatts. Jet, what has your experience been? Are microgrids, privately owned microgrids, customers, or do you see them going toward the utility side?
I think this is actually a fairly complex topic because you've got a couple themes going here. So the number one, I think there's an opportunity for the utility industry to take a proactive leadership role and to be able to support some of the flexibility needed in order to take care of new demands, different sources of energy, so on, low carbon footprint. I think a lot of times microgrids are driven by the fact that customers aren't feeling they can get the level of service, the level of flexibility, adaptability, maybe from the current utility provider. I'm not going to say that's all the time, but I think some of the time that's the case. So there's an opportunity here to take a leadership role, be more proactive, better support. What we see again, and I think it was mentioned earlier by Chuck, it's really a coordination effort, right? So you have all these microgrids, but they're all operating independently. How the heck do you coordinate what's going on across the microgrids, let alone be able to share energy efficiently? It's a complex task. There is really no easy panacea solution. So we see these things popping up, and this is going to take many, many years to really be able to figure out how we're going to pull it all together. And as of now, I don't really have any brilliant crystal ball. All I know is it's happening, and at some point we're going to have to coordinate everything. And I think there's an opportunity for the utility industry to take a proactive leadership role. That's kind of what the call to action here, to continue to sort of innovate. I mean, we see this with solar, and we see this with wind and a lot of the other areas. There's a lot of, Chris's presentation was completely awesome, right? It gives you incredible amount of enthusiasm for the industry and what the proactive thinkers are doing. You're just saying, wow, just step aside. These guys are figuring a lot of really good stuff out. What are the best practices that the rest of us can learn from and the other entities. So it's a tough one, Rick.
And Chuck, I know you have some opinions on microgrids. You've worked
Yes.
You know what the problems are.
Right, there are a number of problems, but just one thing that picked up from the DOE report that we were working on, there's 237 microgrids currently in operation in the US. And they only represent about 7 gigawatts cumulatively, mostly university level microgrids and military. So most of our military bases now are microgrids in some fashion. But keep in mind now, just take a look back into the 1930s and what I consider an equivalent to maybe not a microgrid, but as Rick said, a mini grid. And those would be the early REA co-ops. You had generation facilities distributing only to 5 to 15 distribution co-ops, all completely encapsulated, no other sources of power coming in, and completely self-contained. Those are, in fact, a version of a mini grid or a microgrid, in many respects. Today, of course, they're interconnected, but still.
One comment came in that the Texas grid does actually have some connections to it. It's not completely isolated, but I still think it does operate at a separate frequency than the Eastern and Western. But the next question comes in is, how will FERC's recent decision that allows third-party aggregators to pick customers and deal with issues of demand response and collectively deal that, I think, Christopher, you already had some comment on that. You had some level of aggregation you were describing.
I'm not familiar with the new FERC ruling, so I'm not 100% sure on how to respond to that one in general, but we are looking at ways in which we can aggregate demand to bring the price point down for distributed generation. And that's something that we've been facilitating through our city. But to the specific on the FERC point, I'm not
Yeah,
able to
so
answer.
let me provide a little background then. The FERC Order 2222 requires investor-owned utilities to enable aggregators to provide all the grid services that any large entity could provide. And so that basically means that an aggregator could bid into the frequency control market, or they could bid into the demand response market, or they could bid into the peak shaving market, or just, they can bid into all of those. And I know that you've already got some, and really, to me, it enables the grid interactive home, and it will provide the incentive for EV owners to demand vehicle to grid from the suppliers, all right? Because now they can get paid for putting their power in. So, Chuck, do you have any ideas on how these aggregators will impact the grid?
Again, I think it's a matter of more rulemaking left to be decided. There have to be some ground rules in place for the utilities to be able to manage, just as we said earlier, control, coordination. It's a must. We can't just have a free market reign of all possible entrants participate in, buying and selling the future of our energy grid stability. So I think there's a lot more groundwork to be uncovered here in rules to be set. Okay.
So another question here's for Jet. Will we see the ability to remotely or virtually operate electric power centers in the coming years? The technology seems to be available to enable such a development, but are there security control concerns over unauthorized access to take precedence?
Well, so the answer, the question is that, again, it's a good one. And our perspective is yes, the ability to sort of operate remote electrical centers or operations is something that's definitely within our purview and we believe will happen. There are a series of challenges. So one of them is going to be cybersecurity, which is a big concern. You also have the issue of, remember, we've got a grid for the most part, if we look at across the United States, of some devices out there that are pretty old, right? So you have a lot of aging equipment. I remember there was one utility that said they invested $5 billion in upgrading their transmission network, and it brought the average age of the asset, from 55 years old to 50. So, I mean, it's just massively old. So a lot of these older devices don't really support a lot of this command control coordination. So you've got that issue. So that's going to take some time. And also what Chuck had brought up, the idea of what we call edge computing, being able to compute at the edge. And we think there's some breakthroughs there, because with some technologies, you can actually pull more relevant device-specific information. For example, at a substation, pull it, interpret it, and then get some insights that you wouldn't normally get just from normal SCADA or other sort of monitoring software. So we think there's a lot of advances, but let's don't underestimate the challenge of the heterogeneous, fairly aged infrastructure that sits out there.
So we're coming to the end of our session here at 4 o'clock. I would like to remind you guys that about 3 minutes ago, presumably the Mars Perseverance rover lander landed on the surface of Mars. All right. So that's maybe, an interesting thing. And and one of the items that was carried on that rover is a new autonomous drone that will be taking pictures. All right. And that reminds me that our next session is on drones. And I'm not sure we're going to cover that particular drone in detail, but nevertheless, I would like to just say thank you guys for attending. Thanks all the attendees for coming. We certainly welcome you to go back into the VFairs platform and view some of the previous presentations, because many of them that went on simultaneously and you could spend a long time. Those things are be available for for 3 months. This presentation also will be available for 3 months, and you can go back to the auditorium and go to the sessions, and within a day or so, you'll see a play button appear there. So in any event, thank you guys very much. Really talented. Really appreciate you guys taking the time to work
My
on
pleasure.
your electric grid.
Thanks,
Yeah,
Rick. Good to
Pleasure.
connect
Thank you,
with
Rick.
you, Jed
All
and
of you.
Chuck.
Yeah, thank you.
Happy to meet all of you.
Yeah, bye, everybody.
Here.
Bye now.
Keep it up.
Yep, you too.